this is just kind of an interesting, you probably all know this. Everybody knows Moore's Law? Moore's Law, I guess Moore started back here in the 70s, right? And he predicted that every 2, the cost will come down by a constant factor and the speed will go up by a constant factor and so forth, right? And you might see, oh, what's this? It looks like a line, right? Why is it a line? Is because we're taking the log here, right? So if from 75 to 80, right, well, I guess let's go from 75 to 85. This thing doubled. It went up by a factor of 10, right? So in 10 years, it multiplied by 10, right? So I don't know for whatever that's worth. All right, here. Oh, I don't know. I make weird slides sometimes. All right. This is Jeff's philosophy on life. All right. Should you gamble? Right? People know, should I play the lottery? She says yes. I say no. I say it's tax for the stupid, right? Because you're not going to win. But here's another argument, right? If my happiness, when does it go up by sort of 1 unit, right? So this guy, if you gave him $10, he would get happier, right? And if this guy has $1,000, if you gave him another 1,000, he would be happier, right? And this guy has 1 million, right? You have to give them 1 million to be happier, right? So what's the moral here? Is happiness goes up when you kind of double how much money you have, right? So that says happiness is a log function at best, right? If anything, the studies show that as you get happier, as you get richer, your happiness goes up until your basic needs are met. And then it starts to go down. All right? Right? So what's so that's just saying if you're better off buying a muffin than gambling for $1 million. That's what it says, right? And it's also talking about log functions. All right, growth rates. Here, I don't know why it's log, but here the time is going up in a log factor, right? So it's doubling, right? And here, the input size is doubling, right? And with Moore's law, we're allowed bigger and bigger inputs every year, and we're allowed bigger and bigger running time each year. So if you were to plot, right, so that would be reasonable timelines, and if you plotted linear, any polynomial then becomes linear, right? I don't know, that's kind of interesting here. And exponentials are still exponential. All right, how is everybody doing so far? All right. Okay, now let's define time. You could talk about the number of seconds, which depends on your machine, the number of lines of code, which depends on what do you mean by a line, the number of times you do some operation like addition or multiplication, right? Which of these is a reasonable definition? Anybody want to vote for one? I say they're all the same because they're all within a multiplicative constant and we're doing big O anyway, right? So you multiply one of these by the other, it's by some constant. Definition of size is a little more complicated, right? Could be the number of bits to write down the input, right? Right, so what's the number of bits here? Well, I got 10 elements. How big is this input, right? Small cheat, well, it takes log n maybe bits to write down each one, but we could cheat a bit, right? And we could call, we could call this order n. a time? All right, we'll do this next class. Have a good Monday, Tuesday, Wednesday day.